Welcome to Spring LIB.
Okay, we've been shown a number of molecules, which I will sketch now. An oxygen with two hydrogens and a methyl, a single lone pair, and a positive charge. We've been shown a nitrogen with a lone pair, two hydrogens, and a methyl. It is neutral. We've been shown a boron with two hydrogens and a methyl. It is neutral. And a carbon with two bonds to hydrogen, a bond to a methyl, and it has a positive charge. And the question is, which of these are Lewis acids? Okay, well, what is a Lewis acid? Remember, they are lone pair acceptors. Lewis acids typically, but not always, have some kind of positive charge or empty orbital, or both. Or a strongly attractive antibonding orbital. That's not going to come up here, but that would be something you'd want to consider when thinking about Lewis acids. Okay. In this case, though, we'll simply be looking at empty orbitals. Now, think about the orbital situation of this oxygen, right? It's sp3 hybridized, right? It's got four electron regions, right? So it's using four sp3 orbitals, right? One orbital is participating in this bond to hydrogen. There's an orbital participating in that bond to hydrogen, an orbital participating in this bond to carbon, and then a fourth orbital bearing this lone pair. So it has four filled orbitals. That means it's not going to be a particularly good lone pair acceptor, right? If a lone pair was here, where would it go? Yes, there is a positive charge. That's true, right? But as it turns out, we don't have any orbitals or to put those lone pairs in, right? And we see the same thing with nitrogen. We can conceptualize nitrogen as being either sp3 or sp2 hybridized, but in either case, what we end up with is orbitals for the bonds, and then a third orbital containing this lone pair. Sorry, a fourth orbital containing the lone pair. Every orbital on nitrogen is filled, right? There's nowhere to stash a lone pair. Contrast that with boron here, which is sp2 hybridized, right? It's got three sp2 bonds. And then if we viewed it side on, we would see that it has an empty p orbital. And this is exactly where the Lewis acidity is coming from. That's a very attractive location for lone pairs to go. So that is a Lewis acid. And the picture is almost identical for this carbon, other than that it has a positive charge. But it is, like the boron, sp2 hybridized. And from the side, there's a single bond to methyl, a single bond to hydrogen, another single bond to hydrogen, and an empty p orbital, just waiting for some lone pair to drop into it. It's even more enticing, or more of a Lewis acid than boron, because in this case it also has a positive charge.